Well, the ternary operator in general produces something which is an intersection type, and this is a bit about intersection types. Now, in general, an intersection type is going to be something like this: T1 and T2 and T3 and so on up to Tn, where these T's are some sort of type, and what this means is it's some type or other which can be set to T1 and to T2 and so on up to Tn. In other words, it's some type X, where X has got to be a subtype of T1 and a subtype of T2 and so on up to a subtype of Tn. And if you think about that, not all forms can be intersection types. For example, if you have float and integer, that's going to give you an error because there's nothing that can be a subtype of both float and integer. Think about it. If you had integer, to get from integer to float, you'd have to do unboxing. That would take you up to int, and then widen, and that would take you up to float. But to go from float to its wrapped class, you'd have to go against the direction of the arrow. In the you remember the early diagram that I showed you earlier on, so you can't do it. Integer and float is therefore going to give you an error. So that's and general case. In fact, if you've got two classes in the intersection type, one of those classes must be a subclass of the other, and otherwise you're in this sort of situation here. And if you think about it, that makes a lot of sense, because if we go to this diagram here and you look at just the classes, so ignore the interfaces, then if you've got two classes somewhere or other, say I don't know, say F and K or something, then if you're looking at F and K as an intersection type, then first of all, whatever it is, whatever this X is that is a subtype or this lot, it must be a class and not an interface, because the only things that can extend classes are other classes. You can't have an interface coming out down here. This Q couldn't be an interface, for instance, because interfaces don't extend classes. So it must be a class, and classes only extend one other class. So whatever this X is, if you follow the path from X all the way up, and it must lead eventually to object, it has to pass through, because to be a subtype, it must pass through both of these two in there. So they both got to be on the same path, as it were, up to object from whatever the type X is. So one's got to be a subtype of the other. I mean, it's pretty obvious. And if we got something like this, say K and M and P, K and M, P, then that's going to be the same as just M and P, because anything which is a subtype of M is also going to be a subtype of K. So the K is pretty redundant. So it's going to be the same type. And I think I'll give you an example of it actually being used with the ternary operator. This is the non-numeric case, and first thing to note is that for expression 1 or expression 2, obviously they can't both be primitive, or we'd be dealing with a numeric case. So if just one of them is primitive, the first thing you do is box it, and now we're dealing with just reference types, so you haven't got any worry about primitives. It's all reference now. So basically then we're dealing with something like this, where you've got a type Q and a type S. Okay, so here it is, some sort of Boolean thing equals type Q is, if that's true, then something of type Q, otherwise something of type S. And the question is, what's the type of the result of that? Okay. Well, I've labelled them on here in yellow. And if you think about it, whatever it is, it must be, whatever the type is, it has to be a super type of Q and also a supertype of S. So those will give you the types which are common to both Q and S. And if you look, I've labelled in green all of the supertypes of both Q and S. So you can see it's going to be K is certainly going to be a supertype of Q and S, and L is as well, because there's a path down there to L, and from L to both Q and S, and so on, and therefore all the way up there. Okay, that's the first thing to note. And so therefore, I mean, if you wanted to be a bit perverse, you could say the type was K and L and A and B and C and object, but the specification tells you to prune out some of these. And what you do is, for the intersection type, what it does is it tells you to remove everything which is a supertype of any of these things down here. So you only end up with the ones at the very bottom of the tree. If you look at this green thing, a sort of tree, the stuff that's at the bottom with nothing coming out of it, well, those are the types that you want. And so the expression is K and L. That's the type. That's the intersection type for this particular ternary expression. And of course, that K and L, of course, is referred to as the least upper bound of Q and S, or it can be shortened to just LUB, Q and S, like that sometimes. And well, that's what it is. And if you can, if you look at that, you'll see that it's also, for example, it's also the least upper bound of S and F as well. That's also a I think that's also the same, isn't it? Same, yeah, that's going to give the same answer. So it's not just that. So several things, at least upper bounds, can have the same answer.